This video is for those of you who are huge nerds like me. I'm going to derive Heron's formula for you. So first of all, we have a triangle, and I'm going to call this triangle A, B, C, with sides A, B, C. You should remember from geometry that the normal formula for the area of a triangle is area equals 1/2 base times height, where the base is one of the sides and the height is the altitude of the triangle, which is the distance that is perpendicular from the opposite vertex to that side that you chose as the base. Well, we need to figure out what the height of this triangle is. So most of this video is going to be going through a lot of calculations to find a formula for the height of this triangle. So, things that we know from looking at this triangle. The area is 1/2 C times H. Since I know that the altitude or the height of the triangle is perpendicular to side C, I have two smaller right triangles. Since they're right triangles, that means the Pythagorean theorem applies. So, I'm going to label this segment here as segment P and this segment here as segment Q. So by the Pythagorean theorem, I know that P squared plus H squared equals B squared, and that Q squared plus H squared equals A squared. I also know that P plus Q equals C. And I'm going to go ahead and solve this for Q so that I have Q equals C minus P. And I'm going to use these formulas to help solve for H. But before I get to that, there's one other thing that I need to do first, and this will just make our lives easier when we get to the end of the calculations. In the definition of Heron's formula, we are told that S is 1/2 of the sum of the sides, or 1/2 of the perimeter. So this means that 2S is the perimeter. I'm going to take this formula. I'm going to subtract 2A from both sides. So if I subtract 2A, I get 2S minus 2A equals negative A plus B plus C. And I can factor this so that I have 2S minus A equals negative A plus B plus C. So I'm going to use this later. And then I'm going to do the same thing with B and C. I'm going to go back to this formula for 2S, and I'm going to subtract 2B from both sides. And then I'm going to factor out a 2. Then I'm going to go back to the formula for 2S and subtract 2C from both sides. And then factor out a 2. And I'm going to use these three equations toward the end of my calculation. Now I'm going to go back to these purple equations I have over here. I'm going to start by substituting C minus P in for Q in this formula. So I have C minus P squared plus H squared equals A squared. If I multiply this out, I have C squared minus 2cp plus p squared plus h squared equals a squared. If I go back to my equations, I know that p squared plus h squared equals b squared, and I have p squared plus h here. So I'm going to do substitution again and end up with c squared minus 2cp plus b squared equals a squared. Now I'm going to solve this equation for p. And then I divide by negative 2c. So I have this equation equals p. Now, I'm going to do substitution yet again, and I'm going to plug this value for p back into this equation at the top. So, my purple equation that I had at the top was p squared plus h squared equals b squared. Ultimately, I'm trying to figure out what h is. So I'm going to rewrite this as h squared equals b squared minus p squared. If I plug our formula for p in now, this formula, I'm going to end up having to square that fraction, and it's going to get a little complicated. So I'm going to factor first instead. This is the difference of two perfect squares. So I can factor this to be b plus p and b minus p. Now I'm going to do my substitution. So I have b plus, and our fraction for p was b squared plus c squared minus a squared over 2c, and b minus our fraction for p. Then I need to get a common denominator, so I'm going to multiply b by 2c over 2c and get 2bc plus b squared plus c squared minus a squared over 2c. And then here again I need to multiply b by 2c over 2c and get 2bc, and then I'm going to distribute this negative. Negative b squared minus c squared plus a squared over 2c. Now I need to multiply these fractions together. So when I multiply the denominators, I'm going to end up with 4c squared. And I'm going to do a little bit of simplifying in the numerator. If you look carefully, this is a trinomial that can be factored. And when you factor that, you get b plus c squared minus a squared. Over here, this is also a trinomial that can be factored. But first I need to factor out a negative 1. So if I factor out a negative 1, I'm then going to be left with b minus c squared plus a squared. Then I'm going to keep factoring. This is now the difference of two perfect squares. So if I factor that, I get b plus c minus a and b plus c plus a Over here, I'd have to switch the terms a little bit. So if I switch this around, I get a squared minus b minus c squared. So when I factor that, I get a minus b minus c and a plus b minus c. Now, I put this extra set of parentheses here so we can be careful with our negatives. If I go ahead and distribute that negative, I have negative b plus c. And all of this is still over 4c squared. Now, this is where I'm going to go back to the green equations that I had at the beginning. If we look carefully, b plus c minus a is the same thing as 2s minus a. So when I substitute these green equations back in, I have 2s minus a. This second parenthesis is 2s. This third parenthesis is 2s minus b. And this fourth parenthesis is 2s minus c. Still all over 4c squared. Now we're almost done. We need a little bit more simplifying. So if I multiply these 2's together, I get 16. Divide by 4 gives me 4. And then I have s minus a, s minus b, s minus c over c squared. Now if I scroll back up to the top, this is still equal to h squared. So to solve for h, all I need to do is take the square root. This is h squared. So if I take the square root of both sides, I have that h equals, now the square root of 4 is 2, so I'm going to put that outside the square root. Then I have the square root of s minus a, s minus b, s minus c. In the denominator, the square root of c squared is just c. Now, we are almost finished. We need to go back to our area formula. We have area equals 1/2 c times h. Well, we finally figured out what h is. So, we have the area equals 1/2 c times h. Then the c and the c cancel, the 1/2 and the 2 cancel, so we get that the area equals the square root of s times s minus a times s minus b times s minus c, which is Heron's formula.